Hello everyone, welcome to the channel. This is the second in a 3-video series about digital functions and is all about the DigitalRead function in Arduino programming. As such, this video will talk about the DigitalRead function, explaining how it works and how you can use it in your own sketches. So without further ado, let's get started. So first, I would like to provide you with a brief overview. As you may know, a microcontroller in simplest terms can be called the brain of a circuit. That is, the microcontroller is the component of the circuit responsible for storing and processing the code that's written. So let's make a couple notes here. Microcontroller, controller, brain of circuit. Not two technical terms, but all you need to know is that it's responsible for storing and processing the code that you write. What's unique about a microcontroller is that it has pins, which are these tiny metal legs that attach it to the breadboard, so to speak, and connect it to the rest of your circuit. So if I were to draw a little image of a microcontroller, right, we would see that it has these pins which connect it to a breadboard that's below. Formally speaking, a pin is a metal terminal of any component in an integrated circuit. However, in this case, we're only referring to these ones attached to a microcontroller. If you haven't familiarized yourself with the first video on digital functions, I highly recommend doing so. It'll be linked in the description below. But for a brief overview, pin mode allows pins, these pins specifically, to be assigned as inputs or outputs based on their role in the circuit. This is where DigitalRead comes into play. For inputs, as the name implies, the microcontroller will be receiving data. So inputs equal receiving data. And this could be because it's connected to a sensor or whatnot. When a pin is configured to be an input, the data it receives can be accessed through the DigitalRead function, and this is where it comes into play. So the inputs will be receiving data that'll be going to these pins, and this Arduino microcontroller can communicate with the computer if attached via a USB cable. And so the DigitalRead function reads the value from a specified digital pin, which is one of these, as high or low. So let's make note of this. DigitalRead reads value of specified pin as high or low. And remember, the pins refer to the pins of the microcontroller. To use the DigitalRead function in your Arduino program, write DigitalRead pin, where pin refers to the pin number labeled on the microcontroller. So here's how you would do it. You would write digital with a lowercase d, digital read, capital R in camel case, parentheses, the pin number, and that would be it. When we use this function in programming, most often, if not always, it refers to the use of a sensor or other input. And that means that if your circuit uses LEDs, probably the LED pin number will not be falling in this parentheses. I just want to reiterate that. Therefore, these will not be the components that are so-called being read by the function. If you're having trouble picturing this in practice, imagine this. Your circuit uses a sensor. Let's write this down. Sensor, which has 3 pins connected to a power, a ground, and a pin on the microcontroller respectively. With this setup, you can use the DigitalRead function to access the information from the pin of the microcontroller that is connected to your sensor, the input in your circuit. So if we picture this, we have a sensor with 3 legs, right? Let's call it a visual sensor of some sort. This is going to power, this is going to ground, and this is going to a pin on the microcontroller. Of course, that looks like an octopus, and that's not how it actually looks. But with your program, you would write DigitalRead and the pin to whichever this pin here of the sensor is connected. It's about time that we look at a few examples. Here's an example of the DigitalRead function that I used in one of my programs. In this code fragment, as you can see here, I declared the variable state, as you can see right here, as the number that's returned when the sensor's input is read by the program. Hence the DigitalRead sensor pin, which as we saw above referenced pin 2. However, I could have also replaced the state here in this if statement with this part above, DigitalRead sensor pin, if I didn't want to declare a whole nother variable. Before ending this video, I want to send you off with a few warnings. The first is that it's very important to ensure that the pin you instruct the computer to read is truly the pin used in the circuit. So number 1, use correct pin. This sounds very basic, but believe it or not, I've done it many times and I've witnessed that firsthand. If you don't do this correctly, DigitalRead Function can return high or low values at random, and it really didn't make sense for the first few weeks I was testing my programs. Also, because writing pin labels on microcontrollers is generally very small, especially if you're working with small microcontrollers like the Nano 33 BLE Sense, it can be easy to confuse pins and their respective designations, and that's why whenever I'm working with a certain microcontroller, I always Google a schematic, as you can see here on the right. Additionally, it's important to ensure that when you're using DigitalRead, you're referencing the digital pins on the microcontroller, not, I repeat, the analog pins. A future video will explain the difference between digital and analog signals, but an easy trick to identify the digital pins is either through the use of this kind of schematic as we see here, or by simply using the pins that are not denoted with a capital A in front. So here you can see this is pin A0, A1, A2. In some cases, however, analog pins can also serve as digital pins, but nonetheless, there are some exceptions to this rule, especially depending on the type of microcontroller you're using. So unless you're short on pins, I suggest following to the tricks I just identified.